Okay, if my sound is safe, you guys hear me. All right, guys, we're just gonna get to it because we need to do a bit of building this model, so it might take a bit of time. So we need to. Um, okay, yesterday was such a good exercise that we did, coming up with an idea and actually looking at the process. Can you guys see my screen where I have a notebook? Um, can you guys see my screen?
Yes, we can.
Yeah. All right, so the scenario that we're going to work today is we're just going to create a simple model such as an object detection. So a model that will kind of detect. So when you provide a picture, it's going to actually detect what objects are in the picture. So let me just try and see if I can show you what we're going to actually try uh, and build. So what we're going to do, we're going to try and make our AI tool be able to look at a picture and detect what objects are on the picture. All right. So we will have something like that. So we have, for example, this picture here. We want to create a model that can be able to detect this this information here. Okay, so for example, yesterday when we spoke about our scenario, we said we will create a scenario where um, like a system to detect if the student are cheating or not. But today we're going to work on a system where um, the object can look at the picture and detect what is on the picture. All right. So we're going to get into it. All right. I hope the sound is fine. All should be okay. AI tutorial. All right. So as we said, we now know what is the scenario. So we all understand what is the scenario, what idea do we have. First of all, we need to check what type of what you call that, the type of of computing power that we have. Remember, we now have the idea, but we need to also know the type of computing power. So what we're going to use as a framework, we're going to use TensorFlow. So the first thing that we're going to do is we're going to import and define all the function that we're going to use. So in this case, let's see, we're going to import that faster. So we're going to import TensorFlow as PF, right? So we imported flow. As we've imported TensorFlow, we need to actually check what type of what you call that, type of computing power that we have. So we're going to actually print the type of GPU that we have on the system here. So which we're going to have. So if we check the GPU that we have, I'm just trying to run this to see the GPU that is running on this. Okay, so this is showing empty. Okay, so if it's showing empty, uh, that means that it's not actually using TensorFlow is not actually using the GPU. Okay, okay. Let me check. Can identify some. Okay, that should be fine. Um, all right, so
Matthew.
we're going to create all the input that we need to use here. These are our inputs. So the TensorFlow will be actually a framework that we'll use as well in inference. Right? So there's just a few things that I need to make sure. TensorFlow. Okay, so this is just for inference, and then because we will need to actually download the images from a certain link and download those images, which we're going to be using uh, for our training and for our testing as well. So I'm just gonna comment this to say uh, download image functions. So these functions will help us in terms of download images. We're going to import. We have multiple. Okay. These are just some packages that we're going to need for because we're going to use a URL. We're going to request a URL. What we're going to need to do with the URL, we will need to open it. So we have to import URL open so we can be able to open our URL and actually get the whole picture. Okay, so we have that, and then for okay, so we have that. Okay, so now okay, now that we have this, these packages are just packages that are going to help us. These are actually certain functions, certain libraries that we're going to use to handle those images. So this will help us in terms of um, the images, and then we will need to actually import other libraries that are going to help us with what you call this. Let's see, with drawing kind of when we look at the pictures, kind of drawing a frame around the picture just to tell us um, what type of image is that, kind of drawing around the picture to tell us what picture we're dealing with. Okay, so let's see. Okay, so we're now gonna see draw onto image. Okay, so if we look at that now, in this case now we're going to have a few. Just gonna have. Let's see. We will need NumPy. What else we need? NumPy. that. Going to do the same thing. So basically the first one is going to be to draw on the image. So we need to kind of assign a color. It should be this one. Yeah, color. What else? Okay, we need to call the function draw. Okay, we need to determine the font. Okay. Okay, so, we have that. Uh, okay, and then another thing as well, as we're going to be to actually use the program, we want to be able to measure the time that it takes for our program to work, because it's very important to make sure you know how long it takes to detect images. That's why we need to make sure we also import a time package. What else do we need? Um, okay, so uh, okay, so I'm gonna run this just to check again if it's going to pick up any. Okay, this is not accepted. Okay, so we have this import done. Okay, I think what should be next here. Okay, we're done with the import. Okay, I'm trying to get the images that we're going to use. I think that's fine. Let me see, is there anything missing here? Okay, so I think the next thing that we're going to do, because we've imported everything, we're going to now get the pictures there. So let me just get the the URL to the image. Okay, so we're going to take off. Yeah, there we go. And this picture. Let me try and see if picture exists. If it can download the picture. No. Download, resize. It's not defined. Sorry guys, I'm just trying to get the right pictures. Okay, now it's fine. The picture is there. We just need to create this function here. Size, okay, so all right. So we're going to have a few functions. I'm going to just put a few functions that are going to help us in terms of so that we don't waste so much time. I'm going to put a few functions that are going to help us in terms of um, resizing the pictures, right? So in terms of resizing the pictures, okay. So we're going to have the first function here to display the image. So it's going to display these are the size that it's going to give us 20 pixel by 15. And then we're going to have that image there. And now this function here, to download and resize the image, it's going to give a new width to the image. We have a 256 to that to make sure all the images have the same have the same sizes. Okay, so let's try and run that. And the type of image we're going to have, we're going to convert from RGB to GPEG. Okay, so let's try and run that. Okay, we run that code. And then let's now see if we can download the image and resize it. Okay, the image has been downloaded. Yes, here we go. So we have this image here, which we now need to create a model that can be able to actually the detect what do we have on this image here. So this is just an example of a picture there. So what we're going to do now is we're going to remember this last time when we spoke, we said you can use pre-trained model that has already been trained before in terms of uh, of uh, of doing a certain task, and then all you can do with that model is just import the model into your your work. So here we go into what we're going to use. We're going to use a RESTnet, which is a model that has been created already in terms of of using images and detecting object in image or things like that. So that's what we're going to use. So what we need to do is we need to actually import that module. We will need to get the module that we're going to use. So which module is that? So basically, we're going to import a pre-trained model, which we're going to use in here. I'm just gonna get the URL of that. So this is the URL. Okay, so we get that. Now, the next thing that we will need to do now in this case, we will need to actually load it now into our, so we've determined where we're going to get this module from this website, and then we have just to create a detector to detect actually detector. Our detector will be we're going to load the module. Which module we're going to load? We're going to load this module that we just wrote here. This module here, which we'll get from this link, which is a pre-trained model for image detection. It should be signature must be default. All right, so we now have this, we call this module here, which is the pre-trained our CNN, the CNN that we get this. So instead of us recreating the whole neural network, we can just import a pre-trained neural networks. That's that. Okay. So and then I'm gonna add a function, which is a function to load the images. Whenever we have an image, so we will need to load that image. Load the image, and then remember now that if we load the image now, the image has been loaded. Okay, so now that's okay. This module is still being downloaded from this this URL. So basically, remember for image, guys, remember for image recognition, what neural network is based for image detection? What neural network is the best neural network for image recognition? Guys?
CNN.
CNN, perfect. So here, what we did here is that we will go to this link here, this website. This is a link where we're going to actually import a model. This model is a model that has been it's a CNN network already done, which has been created for image detections, right? Not image detection, but image recognition. So we use that module. So what we're going to do now, what our detector is going to do. So we create a detector. So our detector is going to use this module. So it's going to use this CNN in order to train our model, right? So instead of us retraining the model, we use a model that has already been trained before. So we skip the training level of our machine learning, our model building. Instead of us taking pictures, because we don't have millions or thousands of pictures to start teaching the machine how to detect images. So what do? We take a shortcut. We look for a pre-trained model. We import it into our work. From this URL, we're going to import this module. Okay, I think it's done. We've imported that. And now we have this function here, which will take the image, read the image, and decodes the image, right? So we're going to do that. Now imagine that we've already loaded the image. Now we have an image, but we have a pre-trained model to detect that. So now we need to create a detector. What do we want our model to do, right? How do we want our model to actually start detecting? That will be the most difficult part of this task, to teach to tell our model how do you detect objects, which type of objects, what do you do with those objects. You understand? So that will now be our most difficult task here. But So far, we've already imported all the modules. We have all the function. We've already downloaded an image, an example image, and now we're going to actually create a detector. All right. So are we going to create a detector? We need to look at what we really want. So we're going to create a function, which maybe we can call run detector, right? So now remember here, we are using we already have all the functions to load the image. Okay, we have that. We have the function to draw the boxes. I'm sure we do. We have that. Let me check. Okay, we have the function to display the image. Perfect. We have the function to resize the image. We have a function to uh, create a box around the image to show and then to draw boxes. Yes, we have all those functions. Yeah, that's fine. So I think the next will be just to create the um, create the detector. Okay. Let's see. Excuse me. So we're gonna in Python when we want to create a function. So a function is just a set of code that does a certain that run a certain group of code. So a function will basically be whatever we want to create something. You want to run certain options, so not certain options, certain functionalities in your system. You can create it as a function. And every time you call that function, whatever you write under that function is going to run. So in this case, what we do here, so let's say on your system, when you're going to create your app, so when you're gonna create your app, when you're gonna create your app on your system, what will basically happen is that maybe upload a picture, and then after uploading the picture, you will click on a button that say maybe detect something like that. So when that function is going to run, um, what you're going to have is that you will need to run a function to detect the image, the object in the image. So here, what we're going to do, we're going to create that function, which we're gonna call maybe run detector. Okay, so we're going to run the detector, and in this detector, the argument that we're gonna need, we will need to remember we created a module called detector, and this module called detector will behave just like this CNN that was pre-created. So this module is a CNN that will detect objects in that image. Okay, it has been pre-trained already, so it's accurate enough to detect objects. So what we're going to do here, we create a function that is going to call the detector that we created here. And then what is the detector going to do? The detector is going to use an image that we're going to get from a certain path. Okay, so when you create the function, and then we have that. All right, guys, for those who have coded in Python before, remember they tell you that in Python you need to respect the indentation. What is the indentation? Anybody knows what is the indentation? Anybody knows what the indentation in Python when we talk about
So are
indentation?
you referring to the spaces?
Yes, that's the thing.
Oh,
So in Python, when you create like a function like this, make sure the next line has a space to show that this, whatever code is under here, is under this function. In other programming languages, you're going to use something like this. You're going to use these curly braces, like in Java, and then you use something like this, and then you put all the information inside. But in Python, you don't need to do that. You just have to respect the indentation. Because if you don't have the indentation, the program is not going to understand that everything that you're running there is under this function. So, okay, so remember we already have this function, which is to load images. The function is, where is it? Oh yeah, there's a function. So we're going to load the image. We're going to load the image. Okay, now that the image is loaded, so the next thing we're going to do, we're going to get a converted image, because we need to make sure we have convert. Okay, we have converted image. The converted image. Now, what we're going to do here, we're going to call a function in TensorFlow, because remember, I'm using TensorFlow, so a function in TensorFlow to convert an image. So what we're going to do, it's tf.image. That was part of the theory when we spoke about TensorFlow, where we say if you're dealing with images, when you call tf.images, you are trying to convert that. Okay, let's see. So we have convert image type. So we're going to have our image, and the type will be a float. So remember, guys, what we said last time, that the program will not understand words or things like that. So even an image needs to be converted into numbers, so that the program can do calculations on the whatever information it needs from the image. So I'm going to get that. Okay, it should be new access. All right, so we have that, and then we're going to determine the start time. When should the image be detected? The image should be detected immediately, of course. So what we're going to do, the start time, what am I doing? Start time will obviously be the current time. So the current time is determined as time.time. So when you have time.time, it's going to take the current time. So we have the current time where all operation will start. And then the results that we are expecting will be whatever the detector is going to run. So we have the detector. Now the detector, remember the detector here, um, in our case here, we're saying the detector must run the detector and it needs a path. But now in this case, we don't need to use the image because we've already converted this image. So we want to use the converted image. So we will run all operation on the converted image, not on the original image. So we have the converted image. Okay, what will be the end time? The end time. So we're going to have whatever time, the current time at the time when all operation are done. So that will be recorded at the end time, because we want to print that. We want to show that to for verification purpose. So we want to see when was the start time, when the operation started, when it ends, so that we can see how long is our process taking. That will be very important. Okay, so finally we will have the result. So our result will be in terms of, so we're basically gonna get something like, okay, if it detects something, if it's a tree, for example, at what percentage is a tree? So we're going to have our result as must be a key. We have a key and a value. So we writing it as what we call a library. So because it's going to come with the name of the object that has been detected from the image and the percentage of accuracy. Okay, so and then we have value. Okay, so we'll have multiple item there. Okay, now we have to show it now. So when we want to show, that means we're going to have two prints. Prints in Python, it means that you are displaying, so output. So what we're going to say, we can say something like, okay, maybe we found, so this, does anybody know what this percentage D means? An example of a value that will be on percentage D. An example of a value. When we write a string, like a sentence like this, and then in the middle, we have percentage D. Does anyone know what it means?
Does it mean decimal?
Nope, but you are close. Anybody else want to try? Oh. But you are close to the right answer. What about percentage S? So it's just actually it just means that you are expecting a value there that can be any value. So this value can come from any place in the program. So in this case, for example, I can say we found 6 objects, we found 7 objects, and remember that has to be counted here, the result. So if the result maybe comes with you see here, if the results that we get here, the detector has detected 10 objects. So this value will come in this sentence, found 10 objects. Instead of us always repeating that, we can just say, we create this sentence and then we say percentage D, it means we are expecting an integer. If we put percentage S, it means we are expecting a string, which is a word or a sentence. It's like when you're creating, let's say, for example, you're creating a form where people are writing their name, and then the program will say, good morning, and then it put the name of the person. So in that case, you're going to print good morning, and then you put percentage S. It means we are expecting a word there. And then that percentage S is coming from another string somewhere, another information somewhere, which can be an input that the person type. So if a person type maybe the name, and then it's going to say, good morning, John, good morning, whatever, good morning, whatever. So that's percentage S is the input, whatever input is going to come there. Okay. So that's what it means. So in this case, we have percentage D because we are expecting an integer. I don't know why they just put D there, but it stands for integer. So in this case, the integer that we're gonna expect here will be the result. So the numbers of objects that will be detected in the image. Right, so we're almost done with our function. So our function is gonna convert the image, detect the image, give us the result of how many images were detected. And now it has, remember, we wanted boxes around the images. So the object image with box, remember we've already created a function. Above we have a function to actually draw the box. So we're going to call that function. That function was draw boxes, right? Was that the name of the function? Okay, draw boxes. So what will draw boxes do? Which box are we going to draw? So we're going to take the image. Remember image.numpy. Okay, whatever image we have. Okay, let's see. Okay, and then we have the result, which comes with the numbers of images that have been detected. And then we're gonna call for the detection box, because that's the box we want. We want a box that, we want this one, detection box. Okay, what else? Okay, we want the detection box. What else do we need? Okay, oh, and then we also need to know which element have been detected. So basically, we will have the next result. It's also going to give us what else do we need? Oh, detection. Not a detection score, but we need the class entity. Which class entity? Okay. And then what's the third thing we need? Let me see. That we have the result, and then we have. So if it finds the images, it needs to give us that score as well. Okay, so let's just have it written properly. All right, I think that's it. So now we have the images in the box, and then we just have to do the last thing, which will be to display the image. Display image. Which image are we going to display? We're going to display whatever image is in the box. Okay. Okay. So let me run this code just to make sure there's no errors. Okay, so this is the function to run the detector. So now we have this function. So which means now our system now, whenever you have your data that you have now, so you can just run this function, because this function is going to take the pictures that have been converted, send it into our CNN, run the detector, and then it's going to tell us what is in this picture. Remember, the CNN has been trained before. That means it's understand, it's know that this is a chair, this is what you call that? This is flower, this is trees, and all those things. So this CNN has been trained already. So let's see if our code will run. Does anyone know how you run a function in Python? What must I write for me to run this function? This run detector. So remember now.
Name.
Sorry.
You call the function name.
Can you repeat? Yes, yes. Yes, how do I call the function? Like this function, run detector, how do I call it?
Write its name, like run detect function.
Okay. Run detector, and then what do I do?
Then you pass on the parameters.
Perfect. So what parameter am I going to pass in this case? We're going to have the detector, right? We're going to have the detector. Remember, this is a function. It needs the detector and it needs the path to the picture. So in this case, we have the detector. And then what's the path to the picture? Let's see. We have this picture. Let's say we want to test this picture. What was the path to the picture? You remember here? This is the picture. Okay? So we're just going to copy that. So we're going to run our function run detector, call detector, and then this is the path to our image. Let's run that and see if it's going to work. Let's see. Let's hope it works, guys. It's running. Let's see if we're going to, if our system is going to be able. Now you see how long it's taking. So this is the why, because of the computer. Okay. Can anybody tell me why is it taking long to give us result? Why is it taking long? We spoke about it. When was that? Yesterday, last week? Why is it taking longer? Why is it taking longer?
Maybe because you're using your CPU instead of GPU.
Yeah, because I'm using my personal computer. So whatever operation is happening here may be delayed by my computer. So
You can switch GPU on Colab.
What happened? What you said?
You can switch to GPU on Colab.
Yes. Okay, let's see what's happening. NumPy float 32 object is not terrible. Okay, so where was that? Here. Mm. So where is the problem? Where is the problem? That's what's maybe the problem here. Guys, that's what programming does. You have to actually see why is it rejecting that code. Okay, let me check. Everything should be fine. All the import. Why is this import? Okay. Okay, this time it took. Okay, it found Our system, our thing found 100. Perfect. It works. Works, guys. It works this time. Okay, so it found about 100 objects on this picture. Remember here, that's what I was telling you. The D here is we are expecting an integer. In this case, we have 100, which is the number that we were expecting. All right, so we have this number that we were expecting here. So in this case, we have 100 objects, and the inference time here, which we printed the inference time, it took about 42 seconds to detect this. So now, if you're dealing with something like this in a system where it has to be faster, now you understand why we were talking about the type of computing power that you are using, because it's very important. Because if it takes 42 seconds to detect these images, in certain cases it may not be really reliable. Okay, so we have on this picture we have trees, 37% in this frame here, and then let's see, in this other frame we have 86%. It identified this as a J. This identifies a table. See, so this is exactly what this is doing. Let me see. Okay, I wanna see if we can look for another image, which we can maybe Google an image and see how it's going to respond to that. How the system is going to respond to that. Okay, let's look for another image maybe. Let me see. Let's see, the function is there. In this case, we run it, the downloaded image. Where's the downloaded image? This one. We have to resize it. Okay. Should we try another image?
Yes.
Okay, what I'm gonna do, let me just copy this code so that we can just find an image on the internet and actually put the part of the image there. Let me just make sure I'm sharing this screen so you guys can see. We are actually looking for an image on the internet. I have just typed there. Maybe we look for an image of the type of image. Make sure I'm sharing it. Okay, so you guys tell me which image should we take? Let's see if our system will be able to detect anything here. Okay, let's see this image. Let's see if we can get the URL, because in our case, we are not just downloading the image on the computer, but we are basically getting the URL of the image. This take me to the website. I want the
What if we take a picture in a nighttime setting instead of a daytime?
Oh, you want that?
Yeah, I just want to see.
Okay, let me find then a picture. Okay, let's do that. Let's find a picture in the night time and see how it's going to respond. Let me see that. Guys, anybody can also suggest, if you find a picture, you can also suggest a link to the picture. You will be welcome to test that. Okay, on the picture, open link. I'm trying to find the link address to the picture. Yeah, I'm trying to get the link to this picture now. Anybody else who has a link to any picture, it's okay. You can show us the picture. Yeah, is it here? Right here. Okay, so I got one. Oh, sorry, I'm not even sharing the screen. Excuse me, let me just share the screen. Guys, this is the last thing we do, so just be patient. We just want to test to make sure that our system can also detect new images. So let's see the link. Guys. Okay, so this is the image I have. Let me just try to run that so we can view the image first. Okay, image downloaded. Okay, there we go. Can you see this is the image that I just found on the internet, right? So we're going to run, let's say we call this, let's call it what? Let's call it night's picture. night image. Okay, so now what we're going to do, so this is the night image that we have. So we're now going to, remember we've already created our function. So all we have to do is just to call our function. What is it? Okay, this is our picture here. We've downloaded it. What we're going to do, how did I call the picture again? We have run, we call run detector, and then the picture. What's the name of the picture again, guys?
Night image.
Night image, yeah. Night image. Okay, so let's run that and see. Okay, let's see what it's going to give us. Okay, perfect. So it's detecting here, there's trees. See, so basically it's only detecting trees there. Can you see? Detect some plants here. Detect some plants here. Can you see that?
Sir, are the percentages representing how confident it is that this is a plant or a tree?
Yes, yes, that's correct. That's what it's representing. That's what it's representing.
Okay,
So
sir, thank you.
we'll just try another picture, last picture, and see what it says. Let's get this picture here. Let's replace these night images by another image. Where's the URL? It's here. Okay, so this is the new image. And then let's run that. Run the detector here and see. I'm also downloading another picture, a last one, where there's people as well on the picture, just to see what it's going to do. See, so we're already on 30 seconds. So we need proper computing power to have it running faster if you want to use it in a real scenario. Okay, it took about 43 seconds this time. All right, so here we go. Can you see the full picture is detected as a desk, and then we have this one mobile phone, 84% accuracy. All right, guys, look at this now. This mobile phone, you have mobile phone here, but look here. This one now, it detected at 89% as a phone, but also 23% as a watch. Do you see that?
Yes.
Yes. So it also think that it may be a watch. You see? So that's the thing. So you can use any type of images here. We can be able to actually detect. So we're gonna just take the last image, which will be an image where we have like people. Let's see how it respond to that. Let's see, where do we change the picture? So we have here. So guys, as you can see, in this case, we are using the link to the picture, but we can basically download the image. Instead of using the link, we use the image directly by creating a path to where the image is. So in this case, we are just using the image straight as it is online. Let's download the new, oh, what's happening here? Oh, then can't find this picture. So maybe I use a wrong link. Let's see. I use the wrong link. Oh, download this stuff. Okay, let's see. Let's see how it's performing with this one, and then we can call it a day. Okay, so we have this picture here, which we're going to try. Let's run our detector to detect that image. Let's see, 1 second, 3 seconds. See, guys, it's taking a bit longer. So in a real scenario, you need to think of your GPU. It takes about 43 seconds. Where is? Okay, here we go. You see? So this one here, guys, you see how funny AI can be, you know? It's detect the foods, yeah? Footwear, perfect. Detects this one as a woman. Detect a human face here. Guys, can you see this one has been detected as a boy? This other one as well, detected as a man. You see, because this now is we're using a pre-trained model. Now, if you want to use it in your scenario where you want to actually work on this, make it more accurate, then you work on your own CNN. Teach it to better detect people's faces and everything. As you can see here, this person has been detected as a woman, but look here, we all know this is a woman, but there's a 29% has been detected as a man. This one has been detected as a boy. All right, guys. I hope everyone understood. Is there any question before we can just call it a day?
It's not a question, it's a request.
Yeah.
Can you please share the notebook in the group chat?
Okay, perfect. I'll do it
Thank
now.
you.
Okay, I'm gonna put it on WhatsApp. Actually, we can just change this to other image or something. All right, guys. Can you guys please turn on your camera so we can take the attendance, and then we can call it a day. And I'll see you tomorrow. Because, guys, you see, this is why we talk about all the other servers that you need to use in terms of your computing power, because of these type of issues where it's taking too long. We have 44 seconds here. If this is being used in a system where you're gonna have to detect these images in real time, this is going to be a serious issue. Okay. All right, guys, is your camera on so we can take the screenshot? All right, guys. Thanks for attending. I will see you tomorrow. If you have any question, you can always ask. All right, bye.